Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn about rate of change and slope. This is integral for the next phase of working with linear functions. So let's get right to it. What is the rate of change? Well, let's think of ski slopes. If you think of a ski slope, like the two examples that we have here, if you notice, the ski slope is going down a certain amount vertically, and then it's going over a certain amount horizontally. If you zoom into these real life slopes, notice that the same concept applies. Let's check this guy out right here. We're starting up here at the top, and to get all the way to the bottom, you gotta go down a certain vertical distance, but then you've also gotta go to the right a horizontal distance. Or let's say you're going from right to left. You start up here at the top of this particular ski slope, and you're going down a particular amount of vertical distance, and you're going to the left a horizontal distance. So that's what I want you to think about when we're talking about slope. And formally speaking now, slope or rate of change is the ratio of the vertical change, which is the change in the dependent variable, over the horizontal change, which is the change in the independent variable. It's that simple. It's a ratio or a fraction of vertical change divided by horizontal change. And the only difference between slope and rate of change is that the rate of change actually involves units. So when we think of slope as being a rise over run when it's positive, or a fall over run if it's negative. You rise if the slope is positive, and you fall if the slope is negative. But please note that you always run to the right unless you're going backwards, and we'll investigate that in a second. The slope or the rate of change also has a formula, and the formula for rate of change or slope is the y2 value minus the y1 value divided by the x2 value minus the x1 value. Notice that the y's are the change in the dependent variable and the x's are the change in the independent variable. And x1, y1 is the first point you choose. It's up to you. And your x2, y2 is the second point that you choose. It's up to you. So let's look at how a slope works. Let's say that I have a positive 4/5 slope. That means that I'm going to start here at the y-intercept, and I'm going to literally rise up 1, 2, 3, 4, and then I'm going to run 1, 2, 3, 4, 5 to the right. And I repeat that in a line or in a linear function. I rise 1, 2, 3, 4, and then I run 1, 2, 3, 4, 5. If I was going backwards, then of course I would go backwards and then I would run to the left. For example, I would go down 1, 2, 3, 4, and then I would go 1, 2, 3, 4, 5 to the left. You always run to the right unless going backwards. Even if it's a negative slope, you always run to the right. For example, I want to show you how the slope negative 4/5 works. Well, I start here at my y-intercept, and this time I'm going to go down 1, 2, 3, 4, down, and I'm going to run 1, 2, 3, 4, 5 to the right. Down 1, 2, 3, 4, and I'm going to run 1, 2, 3, 4, 5 to the right. If I were to go backwards, I could start at my y-intercept again and go up 1, 2, 3, 4, and then 1, 2, 3, 4, 5 to the left. And that would stay in constant, continuous slope with the original line. All right. Next, rate of change. Let's find the rate of change. Please remember that the rate of change is the same as slope, except it includes units of measurement. So what do we have to do here? Well, first of all, remember to always find the independent and dependent variables first. Then label the x2, y2 values and the x1, y1 values, and then use the formula. In this case, x is time, that's the independent variable, and distance is y, that's the dependent variable. So let's go ahead and label. This would be my x1, y1, x2, y2. And now let's use the slope formula or the rate of change formula. It's the same thing except rate of change involves units. So y2 minus y1 over, that's a little bit messy here, let's rewrite that y1, over x2 minus x1. So this is going to give me 260 feet every 1 minute. So my rate of change here is increasing by 260 feet per minute. Please note that the slope or rate of change is constant throughout its own linear equation or function, always. If you have a linear function, the same slope continues throughout the length or duration of that linear function. There are 4 kinds of slopes. There's a positive slope that goes up from left to right. You always read graphs from left to right. There's a negative slope that goes down from left to right. There's a zero slope, which is a horizontal line passing through the y-axis, and it does not touch the x-axis. And last but not least, there is an undefined slope, which is a vertical line that passes through the x-axis and does not touch the y-axis. And then I've created this friendly guy here. He's called Slope Man. If you look at the way it works, I have a positive slope as an eyebrow. Then I have a negative slope as the other eyebrow. He's got a very unusual nose, so that U stands for undefined. That's that vertical line. And then he's got 0 emotions. So he has a horizontal smile because he has 0 emotions. It's just a little trick to remember the slope. Okay, let's find the slope of each given line. Well, we always start with finding the x1, y1, and then going to the x2, y2. So in this particular case, my x1, y1 is right here. That's at -1, -2. And to get to my next perfect point, or my next x2, y2, I'm going to go up 1, 2, and then 1, 2, 3 to the right. And I know that this is correct because I can continue it. Up 1, 2 over 1, 2, 3 to the right. And if I want to go backwards, I go down 1, 2 over 1, 2, 3 to the left. So this is going to be 3 over 2. Why is it positive? Because I'm going up from left to right. Next, I start over here at my first point, which I can call x1, y1. And to get to my next point, or my x2, y2, I'm going to literally go down 1, 2, 3. Don't go down 3, -3, over 1, 2, 3, 4 to the right. If I wanted to do another point or find another point, I could go down 1, 2, 3, and then 1, 2, 3, 4 to the right. I would extend that graph. If I wanted to go backwards, I could go up to my first x1, y1 and go up 1, 2, 3 over 1, 2, 3, 4 to the left. Remember, you always run to the right unless going backwards. All right, how about this one? We're going to start here at any point we want. I want to start here at this one, and I'm going to my next point here. So I'm going down 1, 2, 3 over 1, 2 to the right, 1, 2, 3 over 1, 2 to the right. So my slope here would be -3/2. And I think I forgot to write this slope. This was -3 over 4. All right, next, I'm going to go ahead and start here at this first point here. And to get to my next point, I'm going to rise 1, 2 up. and I'm going to run 1, 2, 3 to the right. Rise 1, 2 up, run 1, 2, 3 to the right. So my slope here would be positive 2/3. For my next example, I have a vertical line going through 1, 2, 3, 4, 5, 6, -7 on the x-axis. So this is an undefined slope. And if you remember from the past, when you have an undefined slope and you have a vertical line, it is only going through the x-axis. It does not touch the y-axis. So the equation for this would actually be x equals -7. And for the last example here, I have a horizontal line going through the y-axis at -2. That's the y value here that it's going through. And when you have a horizontal line going through the y-axis, it does not touch the x-axis. So therefore, the equation for this particular line would be y equals -2. And the slope, of course, would be 0. All right. Last but not least, let's find the slope that passes through the given points using the formula. Label, label, label. So they gave you x1, they gave you y1, sorry. And then you have x2, y2. So my slope is y2 minus y1 over x2 minus x1. And that's going to give me -3 over 1, because remember, a negative times a negative becomes a positive. Done. Next, x1, y1, x2, y2, y2 minus y1 over x2 minus x1. I have 0 over -7, which equals 0, so I have a 0 slope. Friendly little hint here. Whenever the y values are the same, the slope is automatically 0. Just a little pro tip there for you. Okay, next example. We've got x1, y1, x2, y2. So slope equals y2 minus y1 over x2 minus x1. That's going to give me -4 over 0. Remember that when 0 is in the denominator, that is undefined. And another little pro tip for you. Whenever the x's are the same, the slope is always undefined. And last but not least, sometimes we do have fractions. So if I've got my x1, y1, x2, y2, y2 minus y1, which is 3 over 1, equals -4 over 1 minus, which is x2, minus x1 of 2/5. Common denominator is 3. That goes to 9. That's -8/3 over, common denominator is 5. That goes to -20. I got -22/5. Please remember, stay, change, flip. And my final answer, my slope will be stay, change, flip. A negative divided by a negative is a positive, so those can change. And I could take a 2 out of this 8, leaving me with 4, a 2 out of this 22, leaving me with an 11, and my slope would be 20/33. And there you have it. That's slope and rate of change. Thank you so much for watching. Hope you learned a lot, and come back anytime. Take care now. Bye-bye.